Okay, so let's look at the statement in R. Okay, so let me pull down a bit. We want to look at statement in R. We're looking at if statement, if else statement. If we have time, we could look at loops, for loops, while loop, and repeated loops. And then we'll look at functions as well. So I'm going to start with statement. And yeah, then this is what I'm talking about. Some instances, you hear people say that they are talking about decision making. Some call it statement. It's the same. Whether decision or statement is the same thing in R. Some call it conditional statement and whatsoever. So let's look at how it works. For instance, I'm going to begin from here. And so if I put this double equal sign here, I'm just testing to find out whether the figure on the left hand side and the figure on the other side are the same. So that is simply what I'm trying to say. And so if I can just run that, that will tell me that it is the same. Yeah, if it is the same, it will return a boolean. Remember, we are dealing with a statement. And if you are dealing with statement, you are practically looking for a boolean. I can go like this. It tells me that it's false because the two of them are not the same. Remember, in R programming, when you use equal, it means you are looking at assignment operator. But when you use double equal, you are looking at equivalence, and that's how it works. Now we can equally check whether what's it, two characters are the same or not. So if in terms of characters, I could just do something like this, and then I will say my name here, and then I'm simply going to say use the two double equal sign here, and then of course, and then I'll just run this. It tells me false. Now, what does R use? R uses R it what it is case sensitive, so it's going to do comparison and find out whether it's the same or not. Now, what about if I had what is it? If I had done the same thing here, I'm just going to copy this. Then I enter inside and paste it. But here and here, I have something like this. If I run that, then it's going to turn true. So it's the same thing I've done down there. And then this particular code here, I'm simply asking if this is not the same as this. And obviously, so when you use exclamation mark followed by equal sign, it means you are looking at things that are not, that you are asking. This one and this one, they are not the same. True or false? If you return true, it means indeed they are not the same. And that's what I've done there. So you can also express this mathematically or in terms of functions. You can write a function for something and then write another function somewhere, then find out what the results will be the same. So it will execute the individual functions first or execute the individual mathematical and then compare them. The example is here. So I'm just comparing 6 raised to the power 2 times 2 and then 6 times 6 times 3. Find out if they are the same. So, and then that obviously will be the same. And so sometimes too, you can also compare, you can do like uh, different comparison. In this case, I am saying that 23 is greater than 12 and 34 is less than 60. So what is going to happen? And I'm using this symbol called ampersand. Ampersand means that two sides of the statement will have to be the same or will have to be true for the statement to accept that is true. So when we do that, we run that particular part. So it's true. It means two parts of the statement is true. So you can write all your function on one side, write another function on another side. Then you try to find out whether the function will produce the same results. So you simply ask that question. And then that's a statement. So for instance, I could have, so if I run the second one, you see that it's also true. Now you could have like one or two vectors. You can compare two vectors. They can either be vectors of numbers of characters, and then you just want to find out whether the entry is the same or not. So what else? what it does here is it's going to compare them individually. It will compare the content, which means that if you are comparing two vectors, the length of the vectors will have to be the same. You cannot compare a vector of 4 elements and another vector of 3 elements. That you are going to be forcing it. So, for instance, I'm going to say paste mama. So I'm just, if I should print only this part, then we can see that we have mama 1, mama 2, mama 3. And then I'm here saying paste mama 3 to 5. So that way, I'm simply going to print mama 3 up to mama 5. So I want to compare the two sides. If I do that, what am I likely to get? Yeah, so obviously they will say 4, 4. They are not the same. So I can, that is what I was saying. I can sum one part, sum another part, try to compare it. And then, so it tells me that it is true. In this case, it's no longer comparing the vectors individually. What it does is it will perform the function first, come and perform the function on the other side, and then compare their results. And that's what is happening. Now, there is a difference between ampersand and then the pipe operator. What you see here, this vertical line is pipe operator. And what it does is it's the same thing as or. Or means we just want one side to be true for the statement to be true. We don't we are not actually interested in the entire statement to be true. And so look at what is happening here. So I'm just going to run that, and you see that it is false, which means the two statements are false. If one of them is true, it will return true. And that's how we're able to compare or use or to be able to compare. So either the person is this or the person is that. So one side has to be true. If you're using ampersand, which means and, it means the two statements will have to be true for everything to be true. Okay. So for instance, if I have here, if I have 3 and then I do ampersand a 4 and I do another ampersand 4, if I run it, it's going to say true, right? So, oh no, I've done 3. 3, okay. So, that's exactly what I was trying to say. For here, it's just going to compare the two figures and then it will return that they are true, they are the same. So, okay. Now, what about if I'm using the pipe operator where I'm supposed to, let me drag this a little bit on the side. So if, so here I am just simply using or to find out. And then it means one has to be true. Obviously it's going to be true. And so now there is this that we use it so often when it comes to statement. So it is called member of percentage in percentage. It means member of or found in. So for instance, I just wrote a character here. So I'm saying that Paulina is a name. I want to find out whether that name is found in this vector that I have here. So what I'm simply doing, I'll write the name and I'll say, is this name found here? And then when you run it, if it is there, it will return true. If it's not there, it will say false. It's saying false because this particular Paulina is spelled with an uppercase P and here with a smaller case. If you come here again and then we run the second line, it says it's true, which means what is it is the same thing. You could as well also check for a vector. For instance, you can check whether these two names are found here. So what is going to happen is, let me run it and you look at the results. So it's going to take false and then true. So it's going to check to see whether Eben and then Paulina is there. Paulina is not there because of the difference in the spelling, but Eben is there. So it will return false and then true. If both of them were there, it will return true, true. And that's how it is. So here, let's look at something here. I just decided to create an attribute here. Then I created, what is it, another one. And then I'm trying to find out whether one is found in the other part. So try to run that. And then you see true, false, and then true. So you can have two vectors, and then you can decide to compare them to find out whether some members of the vector is found in the other vector. So it's a way of like, so if you have a large database and then you want to find out whether some individuals exist within the database, you can just use percentage in percentage to do that. So it's the same thing I'm doing here. So here we are trying to find out, we are using 3 to compare, we are using this particular vector to compare to 3. So each element will be compared to 3 and then throughout. So wherever it is true, it will return true. The same comparison we are doing here, but using a greater than or equal to. So what we are saying, we are comparing this 3. Is it greater than or equal to this? Then it will return true. This one will return true. It might return true throughout. As you can see, true throughout. So I also have a variable here. I'm just going to run that particular variable. And then what I'm trying to do is to simply show us how to be able to use this simple conditional statement to be able to maybe isolate people who have higher temperature, maybe in a hospital or something. So what I'm going to do is I've just simulated some 20 people, which is here. So let me clear my console a little bit, just browse it. And then I come here to say I have from variable to 1 to 20, and I'm looking at temperature. So my data frame is a temperature. So if I print it like this, check something, you will see that if I fold it up, you will see these are individuals and their temperature ranges. Okay. So we have A, B, C, D. So A could mean Abena, where the big bar, comfort, truth, and then whatsoever. These are individuals with their temperatures. So we now want to say that we want to isolate people who have higher temperature. The normal body temperature is 37 degrees. So what we simply do is we say high temperature, we create as a variable and we say that so temperature is here. Temperature we have already created as a data frame. So we are selecting the column that contains the temperature, which is column 2. And we are saying that whatever that is greater than 37, is it greater than 37, we should pack that variable into the high temperature. So when we run that, it's going to pack that into high temperature. So what will happen is it's going to return booleans, true, false, true, false, and the results will be packed in high temperature. So what we're going to do, we created a new variable, a new column, which is called temperature underscore R. So, and then we pack the new one into it, the new variable that we created, which contains either high or low temperature, represented by true or false. Then we pack that, and then the variable is created. So look at, so the variable is created now. So now if I should print temperature alone, you will see that I will now have true, false, true, false. Wherever you see true, it means the person has higher temperature. If you see false, it means the person has low temperature. This what is the easiest way to be able to isolate. If you were working in the hospital environment, it becomes very easy for you to do that. Okay, so now what about if we now want to isolate only those who have the higher body temperature? So we will simply just select, we use this particular code to select. So we say temperature and we open an index, which is a square bracket, and we enter into that and go to the rules column and say that check through the rules, any rule that contain true in this particular variable, in this particular column, anything that is the same thing as true, print that out. And then it will simply print that out. So when we do that, it will isolate only the true. And so these are individuals who have high body temperature. Very simple. And so this is how it works. That's how statement, we actually apply statement. So here, look at something here. I could have some temperature range here. And then we have 3 towns. So as well, we could just come here and check for Tamale. So it will simply select Tamale for us. And then if we say any region or a region with T, then that is going to select. And then, of course, the same thing here is the same thing. I think we've done some of these things. So these are the conditional statement. Now let's look at the second part of statement, which is called if, and then if-else statement, and then else-if statement. Now, the if statement, when you start with if, it follows closely with the condition that is given. And if that condition is met, it will execute anything within this particular So declare a variable, and then we say if that particular condition is met, then write your command inside the body, inside this curly bracket, and then you run it. For instance, I'm going to declare a variable called x, and then assign a value to it called 30. If I do that, then I'll simply go and say that if I'm asking whether 30, which have been assigned to this variable called x, is an integer, is this particular x an integer? Then I'll open and close. If it is true, then we should print that x is an integer. And then you simply run all of them, and then you should print that x is an. So what is it? If I finish running that, I expect that it should return x as an integer. Okay. I don't know if I have to run the x again. No. So I have assigned, okay, let me run this line again. And then if, well, I don't know why it is not printing. Maybe I'm making a mistake somewhere. So I'm assigning a new variable, what is the value to this variable called a. And so simply I'm just going to run that and come. I'm saying that if a is greater than 40, what will happen? Execute this particular code here, a plus 3. And then what is it? When I run it, I'm expecting to have some. I don't know why. Maybe I'm making some mistakes somewhere. So let me assign a character to it. And then I'm saying that if it is a character, if y is a character, we should print a is a character. Yeah. So that's what I was trying to do. So we printed a is a character. So we simply give the if statement. We declare a variable. We come and then run it, and then see what will happen. But see, this is one interesting thing about IT. Let's look at this code. What the difference between this and then the one on top here. So let me come here and run this. That's 30. Okay. So, and I'm now saying that. Okay. So what happened was that I was asking a question, but in if statement, if you run it and the the statement is not true, and you don't have the negative statement, the code will just remain silent because you're using only if. Okay. Now, if I add L to this, if I add capital L, then and then I now assign it. If I should run it, it will tell me that x is an integer. Okay. So if I come here now, let's look at something. I've assigned 34 to A. So I'm going to run that, and I'm saying that if A is greater than 40, then we should say A plus, we should add 3 to A. But A is not greater than 40. That is why when I ran it, nothing happened. So if I run it, because I'm using just if, okay, if I were having else would have said that, okay, if it is not, what is it like that, so what will happen next? And then I'm coming to that in a jiffy. So here, for instance, but if I say that, if I should put this place 50, 50 is greater than 40. If I run again, you will see that my answer will be 53. Because I'm saying that if A is greater than 40, A, we should print, or we should say A plus 33. And then let's see. So, and we have assigned it to A again. So now let me come here and let me try see what if I can run A. So we see that A now gives me what? 53. And that's what I was trying to explain. So you give what is a statement, a conditional statement, And then if the statement is met, then you are good to go. I've already done this. So here we're looking at modulus. We use this one to be able to check numbers. So I'm simply saying that I'm still using the if here. Okay. So what we're simply saying is we're trying to find out if you divide a by 2, and this is modulus, percentage with modulus, and the result is not equal to 0. The remainder is not equal to 0. If you understand modulo, you are dealing with remainder. So you divide a number, and if there's a remainder, for instance, if I divide any number and then by 2, and the remainder is 0, it means that that number is an even number. So this is what we are coming to do here, just trying to find out. So it's an odd number. Yeah, as you can see. So let's look at if else. In this case, we are looking at, okay, if the positive statement is, or if the condition is not true, so what is the next? So here I've assigned a vector of characters. What if true? So in each of them to X. And I'm saying that if truth is a member of X here, remember the conditional statement we were given. If it is a member, we should print that truth is found. Else we should print that truth is not found. And that's it. So I'm going to highlight the whole thing and run it. And so it tells me that truth is found. It's not found. So you understand why the truth here is lowercase, and the truth here start with the truth here. That's why the condition is actually starting with an uppercase T. That's why. So that's if else. It's practically the same here. So you give the statement and you are saying that if it works, then if it is true, print it. If it is not true, you can decide to print the opposite. And here you notice it printed the opposite. So here we are given another same set. So we are assigning this set of characters to X. And we're saying that if truth is a member of X, this set of characters, that's what we mean. We mean if this set of characters is found in this particular vector that contains all this set of characters on top here. So if they are able to match, then what should we do? We should print that. We should say truth is found the first time. If it is not found, then we come again and say that else if. Then we give another condition. We are saying that if this one was not found, so we should try truth, this particular spelling pattern, whether it is also found or not. If that one too is not found, then we can come again and do this. And then we can continue giving all these conditions after that we run. At least if all the conditions is not met, then we know that that particular, I say truth is found the second time. So it means the first time it was not found. The second time it is found. This is very useful when you are dealing with like forensic analysis in police case. Yeah, maybe you have an attribute of a criminal, a suspected criminal, and then you want to test those attributes against a database it is somewhere. But maybe the attribute first, the suspected criminal had bushy hair, maybe had a fair complexion and whatsoever. Later on, he has transformed all these things. So you can try to give the condition in the first place and say, okay, if you find bushy hair in the attribute, then we can say it. If not, we should check if we found maybe a fair complexion, or if not, we should check. So we can continue to check the conditions, and later on, then we have our results out. So here, you see, it's practically the same thing I have here. And then I'm just going to run that. You can pause the video and then look at the code, how it is being written. So you first of all declare your variable, which is here. We've declared it as TT. You come and give the condition, saying that if, then you open your bracket and type the condition over there. After that, you open your curly bracket and just do enter on you. Enter, so it will automatically slide this way. And then you simply run this. So if you wanted to end at if, you would have run it up to this point, and then it will just run properly. I can still run that part, and then it will run properly. But you might not get any results because the statement is not true. So, so this is what we call the else if. you can use that to be able to. So I could have just highlight the whole thing, then I'll just run it at once, and then what is it? Nothing is there. You see that we have not found anything. We have not found anything that is related. Truth was not found. Truth was not found because you can see there's a small truth here, and then this is another one. But the truth is spelled in uppercase letters. So we checked through all the conditions, and then there is no truth. So no truth was found. So let me run the whole thing again, and let's see what happened. But I was expecting that this should be the. And so here we gave the first condition, and we say if the condition is met, print this second one. And we're saying that if that, so we should check the second condition. If it is met, we should print the second one. And then third, we say else, print no truth was found. And this is how it works. So we run it, GT. Okay, yeah, so there's a little problem here. I think, yeah, that's why we're not getting the. So here, if as we run the whole thing, it will tell us, yeah, that no truth was found. So it will check the two conditions and they are not met, so it will print the last one. So it means that if you have more than 10 different conditions, you start with if, then you now go with else if, else if, else if, and then the last one will be the condition that will be printed if the entire conditions are not met. And in that case, you say else. So you don't give anything. Because you're not giving any condition, you don't open, close, open and close bracket. You simply bring your curly bracket, come down, and then print whatever that you want. But immediately you say else if, it has to follow with a condition. If there's a condition, else alone, there's no condition. And then that is it. Okay, so we come here, it's practically the same thing around this particular place. You run that, and then truth was found in the first place. So we could have done that to try the rest here. Let me do this way. Somebody want to, yeah. And so here, these are the same thing. So we can print, this is an even number. If not, we could check the other one. So this is an assignment. Write if else statement to print a prime number. So here, look at something. A prime number is an odd number. Is any odd number except 2. So a prime number is any odd number except 2. And we know that an odd number cannot are numbers that are not divisible by 2. Check something here. Here I'm going to use 2 conditions to print it out. So first of all, I declare 8. Okay, let me declare 27. So I declare a variable, and then I assign 27 to it. And so I came to say that if P divided by 2 and the result is not equal to 0, it means that it's an odd number, because odd numbers are not divisible by 2. So when the result is not equal to 0, it means it's an odd number. And then you give another condition. The second condition is that and P itself is not equal to 2. So first of all, the value is not divisible by 2 and the value is not 2. This is how we assign multiple conditions to be able to. So when I do that, I'll just highlight the whole thing and then come. And so we say that P is a prime number. That's how you are able to check whether it is a prime number or it is not a prime number. So there are instances one condition may not be able to give you. So you have to combine 2 conditions. And then that is what happened. Now, let's check this instance of police case. Here, we're just looking at cars and their futures. Okay, maybe a car is missing. You want to check. So these are simulated car numbers and then chassis numbers. And we are simply saying that if Kantanka is found within this particular database features, and then this chassis number is found in this particular database chassis, which is here, and then the number plate is found within the vehicle numbers database here, we should print that that is the missing car. Else we should print that that is not the missing car. So I'm going to run that. I don't know what I've run all this. So I'm going to come here and run the whole thing at once. So that is not the missing car. It means all the features were not met. Okay. So this is how to be able to check, like in the case of forensic checking. So you can check all this. Let me scroll them slowly. Wherever you can just pause your, and then you can try to look at that. You assign your value. So this is vegetation is 3, and we are saying volume is 2. So we are saying that if vegetating type is equal to 3, then we should calculate the mass. And so in that case, I'm just going to do this, and then when we calculate the mass, it is actually, the vegetation type is actually true, is 3. If I change it to grass, you won't see any kind of, okay, let me even change it. Let me say trees. Then come and run the whole thing again. You won't see anything because the condition wouldn't have met. The condition would not have met. So here, I'm saying that, so I'm assigning vegetating type equals to 3, volume this, and then this. And so if I come and then I run the tab, don't expect anything, but it is printed. I think if I have to change, this is the only thing that has been calculated, and that's why you have the 4 there. So these are the various ways you can check all this. What is it? If I run this, what I'm simply asking is a member is equal to Paul. And so if member is the same thing as Paulina, then member is equal to what? Female. Else member is what? A male. And then, so these are what we call conditional statement, or sorry, if statement and whatsoever. You just look at that if the condition is met. So quite a number of them. I will just simply scroll a little bit. Now we also have switch statement. I have not spoken about switch statement. I think I should do it as a full topic by itself. And then, okay, so now let me quickly run through loops. So we have something we call loop. A loop is like you are iterating over something over and over and over again. Okay, and so you are able to what is it, to be able to print out. You are looping through. You are finding. You are scanning through a set of data, and then to pick out the kind of data that you want and apply any kind of function or mathematical principle that you have on it. So we have different type of loop. We have for loops, have while loop, and then we have repeated loops. So in R, we are going to start with the for loops. And for the for loop, this is how it works. You use the function for, and you say for, and then you simply indicate item in a list of items. So, and then you open your curly brackets and then do something to the item, and then you print your results. That's all. So for instance, I'm saying that for I in 1 to 4, it means that I represent all the numbers we are counting from 1, 2, 3 up to 4. So for 1, 2, 3 up to 4, which is now being assigned to I, print I raised to the power 2. So what is to do with that is to pick 1 raised to the power 2, 2 raised to the power 3, and then in that order. So when you do that around here and then you run it, you should be able to print your numbers for you. It makes work a little bit easier. And then for mark in 20 to 30, print mark divided by 2. So here you have a vector of a set of marks or scores seated somewhere. And then it's from 20 to, and you want to at least divide any score that is 20 to 30. And so this is what you do. Simply write your for loop, and then it will just scan through and then divide each of them. And that's what is it we are doing. For marking this and this, print. So for here, what we are doing is we are trying to print in the form of like a data frame. In the first place, we are looking for marks in 20 to 30. So that will be 20, 21, 22, 23, up to weighted to 30. But here, we're not just printing only the max. So we'll print the max first, come and print the max divided by 2, and come and print the max modulus 2. So it's going to come in the form of a data frame. And then, and that way, you just use one. So you look at how it came in the form of a data frame. Forget of the arrangement, but that's how it is. There are actually 3 things there. So that is how it works. So for Mac in this and this print, Mac raised to the power 2 is the same thing. You can just run it. And so what you're going to have it over there. For a letter in letters, print letter. So it will print A, B, C, D up to Z for you. And then it's that simple, A, B, C, D, all the way to the last one. And that's how it is. What about if you had said for a letter to this, we should print letter, and then we simply come here, and then you put your square bracket, and then you can say 1 is to, let's say, 16. It means we are not going to print all of them. We are going to print from A to, so in this case, you see that it will print, and those that are not part is going to leave that as NA, 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 then in that order. Okay, so these are the ways through which we deal with this. So here we're looking at weight in T. So let's say we are looking at weight in run if. So we're just looking at 30 different variables, a minimum of 3 and a maximum of 10. And we are saying that print weights. So it's going to print all the weight for us. And then, yeah, it will print all the weight for us. So these are the way we deal with for loops. And then you can check all of them. They are quite a number. So let me check. There are instances you could add a little bit of mathematical operations to it. And so here we are looking at some scores. So I've assigned this particular scores. I've created it as a variable, and I'm saying that for I in scores, print first I squared, and I plus 8. So that's the same data frame I want to print out, remember. And so look at how the data frame comes out quite neatly down here. And so it makes it very easy. So we've selected the I, and we're now saying that print it, and we're using a vector because we're going to print more than one resource. So I have to use a combine function to combine the results. So we are saying I here, I square, and then I plus 8. So it will simply select the numbers, print them out, and then the same numbers it will square each, and the same number to add 8 to each of them, print in the form of a data frame. See here is the same thing, body metrics. So we sample 2 to 6, and we are sampling just 10 with replacement. I was saying that for metrics in body underscore matrices. And so what do? We should print C metrics, then matrix times 10, matrix times 10 divided by matrix raised to the power square. And so let's see it will perform all the mathematical operations and give us our data frame with all the answers. As you can see down here, it's quite simple. That I will just scroll down a little bit, and then these are all. You can just pause the video, and then you make sure that you are able to repeat almost everything here we have here. You can do it in any way at all that you want. Now, let me quickly go through this. We have instances where you can do your for loop using an index. So for instance, for a volume in 1 equal to a length of volumes. So in this case, I would have created this particular variable called volumes. And then I can now simply come and say, we are now going to calculate, let's say, 2 times 3, 2.3 times the volume raised to the power 1.2. And that's going to give us, and then we can now say that our mass is equal to our pounds, and mass conversion is equal to this. So we print pounds. But I did not create anything for volumes. So if I run it, I'm not too likely to get volumes, to get the results. So I needed to create volumes. So maybe I could just come on top here and just put this thing here called volumes. And then I'm just going to assign some figures there, and let's look at something. So I'm just going to say 2 to, let's say, 12, around that. So this way, I will now have some numbers there. So if I come here and then I do this, then it should be able to calculate, convert everything to pounds for me, as you can see it. All right, so this is, you can store some of these things. So, okay, this is how to be able to store your for loops. It's just too much, and the video is getting too long. For a kilometer in run if this and this miles. So we're just trying to convert what a kilometers to miles. So what do? Well, for a kilometer in, we have 20 different variables with a minimum kilometer of 3 and then 10. And we want to convert each of them into miles. And we know that 1.6 is the same thing as a kilometer. So we say 1.6 times a kilometer. And that's it. We pack everything to miles and then we print miles out. So this code is not going to run successfully because of something I've noticed. Yeah. So what I'm going to do is just going to take out this, and I'm going to run that all over again and we'll look at something. Yeah, and that runs properly. It has converted it. It will convert it automatically for us. So now we can also look at what is it? We have other things here. So we have some values we have created on top here, which is stated here. We are saying that we have a vector mode is equal to this, length is equal to the length of the volumes that are created on top. For a kilo in 1 to the length of dd, the miles is just, let's try and see if this is going to, so we're just going to plot an environment and then see what will happen. Yeah, and then you can see that you can also add even plots in it and look at how it looks like. The plot is here, quite beautiful. And then that is how we can equally use the for loops to be able to just plot. So what we've done here is simply, we just created a vector. And then we're saying that this is a function. And we're saying that the mode is equal to numeric and the length is equal to this and this. And then we pack everything to environment. Okay? And so we now say that for a kilo in the length of dd, this dd that we have created, then we are saying that we're creating a variable called miles. And so miles is the same thing as 1.6 times a kilo, like the kilometer that we use. And then that is there. And so we also say that environment is equal to kilo. And then inside the environment, we are selecting the kilo, and then we come and then pack the miles into it, and that's what we plot the environment, and then we are good to go. So let me see. There was something that I wanted to look at. Okay, the last 3 things I need to look at is how do we do for loops on a list? A list, okay? We do for loop on a list. You know, if type of data type, we have list, we have data frame, we have matrix, we have arrays, and then we have vectors. So I'm just going to look at how to be able to loop through a list, to loop through, let's say, a data frame and then a matrix. So we start with a list. I've created a list here, list 1, 2, 3, 4, 5, and I packed it to something called my lists. Okay. So let's try and list and then look through. So we say that for I in the sequence along is a function of my list, this particular list here, the sequence along my list. So we should say we create a variable here, and then we say we are creating this particular variable called current underscore, and then we say my list, this list I've created. Then we look for I in it. I represent each of them, 1, 2, 3, 4, and 5. So what do? We print, paste. The current element is, we say current underscore element. You see, this particular statement will be printed. the current element is, then it will then print 1. The current element is this, and then in that order. So let me run the whole thing, and then, okay, let me just click undo here. And so I'm going to run the whole thing, and you see how that works. So this is, the current element is 1, the current element is 2, then in that order. It's a very simple thing. You create your list. Here, it could have been characters, you see. So the current person is the person's name, the current person is that, then in that order. It could have been anything. And then you simply use this technique. So sequence along is, so I'm saying that pick the sequence along this, okay? And then we come and say my list and go to this index. When you do this, we go to this is how we, just like the way we use square bracket to be able to index a vector or a data frame and then select a specific position value. In lists, we use the square bracket twice. It's the same thing. So here, if you want to also subset a list, you use the square bracket twice, and it's the same. Okay. Yeah, so just pay attention to that. That's what we've done here. Okay, so for loops on the data frame. Let's look at how to do a for loop on a data frame. So I'm just going to create my data frame here. So this is a data frame I've created. That one I don't need to, oh, sorry about that. That one I don't need to waste your time. I already know how to create data frame. Okay, this element is not part of the whole thing. I think it's supposed to have been on top here. So I'll just put it here. So now if I come this way, I will simply run it. Yeah, and that works just well. So now we come and say that we have our my data frame on top there. So we say for I in a sequence length, and then we use the n row of the data frame. So we are looking at the n row section of the data frame. We enter the body and say, what do we do? Create a new variable and say that my data frame, and then we are selecting I, which this particular I that we have here, we are selecting it. We are using the rows column to represent the I here. And then we print paste. The current row is, then we use to string current underscore row. Then it will now be printing this here. So it will print this as a text, and then that particular text will be followed by whatever that is contained here. Is contained in this particular variable, and that's all that we've done there. I'm just going to highlight everything and run it, and then it will print everything for me. It will see the current row is Joyce, and then it's 40 years, and he's a male, and then in that order. So you see how it is. This is the data. Take time, listen to the video again, and then you are good to go. Now, let's look at a data frame of matrix. So I'm going to create a matrix, which I've created, which is here. And then we're saying that for I in a sequence length of n row of my matrix, what do we do? And then we say for j in the sequence length, or that is n core, the same my matrix. So here we are looking at the rows and columns of the matrix. So that's what we are using the for. So we now create this particular variable called current element. And what do? We assign we look for the matrix, and just like the way we subset matrix, we look at the row columns, which we presented by this I, and we look for the columns, the row section represented by I, the column section represented by J, which we have already, given the conditions here. And then we now say print, and then this particular text will be printed, and then we'll go and say that after we printed this text, add this current element into it. And the current element is here. Here. And that's all. So just going to close this up and then run it, and then it will print the current element for us. And that's how it is. So beautiful. So, ladies and gentlemen, I will stop here. and then I'll upload another video, and that will be on functions in R. And if I have time, I will just throw more light on while loop, then repeated loop. Then I'll go straight into functions in R, and then functions to be able to analyze it. And so that's your video of today. If you love what I'm doing, thank you very much. If there's anything you don't understand, you can just say hi to. You can send me a message. You can do it, or you can send me, or you can comment, or you can contact me. My details are always here. My name and my number is here, and then I'm always ready. My name is Bipa Bright, and I'm a bioinformatician by training, and also a data scientist. So thank you. I'll see you some other time. Bye bye.